Hello, welcome to InfoFire, the fireside chat series from Information Matters. InfoFire brings visionaries and experts in diverse domains to share their perspectives and stories on a chosen topic. Each episode is a conversation between our guest and your host. I am Shalini R, your host for this series. I am an academic with more than 4 decades of experience in teaching and researching information. I founded 2 educational institutions, the International School of Information Management ISIM at the University of Mysore with a seed grant from the Ford Foundation, which is the first iSchool in India, and the Myra School of Business with a focus on triple bottom line. In this episode of InfoFire, I am in conversation with Dr. Mike Thelwall, Professor of Data Science at the Information School, University of Sheffield, UK. The topic of our conversation is large language models, research evaluation, and SciMetrics. Let me take a couple of minutes to introduce our guest, Dr. Mike Thelwall. Professor Thelwall, a well-known scientist researching in scientometrics, meta-science, and the social media from a social science perspective, is currently leading an ESRC, that is the Economic and Social Research Council funded international meta-science project assessing the value of large language models like ChatGPT for research evaluation. He is also involved in an international project studying scientific retractions and misinformation in the media funded by the Calouste Gulbenkian Foundation. His research primarily applies quantitative methods and artificial intelligence to social science issues, particularly research evaluation. Social media analysis is another of his areas of interest. Before joining the University of Sheffield in the year 2023, Dr. Thelwall worked at the University of Wolverhampton from 1989 to 2023, teaching mathematics and statistics and researched on educational technology before switching to library information science with a focus on web indicators for research evaluation, that is webometrics. He founded the Statistical Cybermetrics and Research Evaluation Group in the year 2000 at Wolverhampton and led the group focused on researching bibliometrics and altmetrics, webmetrics until moving to Sheffield. His work has been cited 56,000 times, and in the year 2015, he received the D. Sala Prize Medal for Scientometrics. Dr. Thelwall's H index is 113 and I-10 index is 500. He developed the SentiStrength, a sentiment analysis program for opinion mining. In fact, during the 2012 Olympics, the London Eye was transformed into a social media-driven light show for the Energy of Nation project by ADF Energy. Tweets about the London 2012 Games were analyzed for sentiment using Centigraph developed by Professor Mike Thelwall. Positive and negative sentiments were visualized in real time with yellow and purple lights, creating the world's first Twitter-powered light display. Dr. Thelwall has collaborated on many international multidisciplinary research projects applying innovative bibliometrics for various organizations, including the United Nations Development Programme (UNDP), the United Nations Food and Agricultural Organization, the Belgian government, Nesta UK, UK Research and Innovation, that is UKRI, ESRC, and Gulbenkian, and also the JISC, Joint Information Systems Committee. He was part of the Metric Tide group that evaluated the role of bibliometrics in the Research Excellence Framework, and now he sits on the UK Forum for Responsible Research Metrics. In the year 2022, he led a team assessing whether artificial intelligence could play a role in future research assessment in the UK. He is also docent, Department of Information Studies, Abo Academy University, Finland. He is a senior associate editor of Journal of the Association for Information Science and Technology. He is also a member of the editorial boards of many journals, including International Journal of social research methodology, professional de la information, data science and informatics, quantitative science studies, Journal of Data Science and Information Science, the journal SciMetrics, the Journal of Information Science. He is also the author of several books, such as Quantitative Methods in Research Evaluation, Link Analysis, and Information Science Approach, Introduction to Webometrics, Web Indicators for Research Evaluation, A Practical Guide, Word Association Thematic Analysis, a social media text exploration. With many accomplishment accolades to his credits, we are really privileged to have Dr. Mike Thelwall as our guest for this particular episode of InfoFire. Without further ado, let's go over and have the chat with our guest, Dr. Mike Thelwall. Hello, Mike. Welcome to InfoFire, the fireside chat series from Information Matters. Thanks a lot for this opportunity to have this conversation with you on the topic of large language models, research evaluation, and SciMetrics or informatics. Okay. Well, everybody knows that many technologies have been agents of creative destruction. But what sets the LLMs apart is the speed and the intensity of its impact. If we say that LLMs are generative AI in general, are talk of the town, especially in the context of science and scientific research, I think it would be an understatement, right? Everyone has experienced and seen this impact on science and scientific research. It has not only accelerated and sort of redefined science and scientific research, because AI has become both the muse and the maverick researcher itself, right? So in this context, in the scenario of science becoming increasingly what they call as co-created with AI, how do we do this research evaluation? Naturally, research evaluation, scientometrics or SciMetrics, as I introduce the term SciMetrics to encompass the entire gamut of scientometrics, bibliometrics, infometrics, and altmetrics. How does this evolve, adapt to this changed scenario or a new republic of science, if you will? What kind of changes are required? How do research evaluations, in a sense, maintain or retain the integrity, relevance, etc. of research evaluation itself? These are some of the questions that are weighing researchers as well as research evaluators. So in this context, you have contributed immensely and you are an expert in this field. We would like to seek your insights. Particularly our audience would definitely be interested in knowing your insights on how this field has, you can say, redefined itself or transformed itself. So in this context, I have a couple of questions to you. Let us first begin with your own personal journey, academic journey. You started your academic career as a mathematician and transitioned to informatics, right? So what sparked this shift from mathematics to informatics? What kind of, was there a pivotal moment in your life which made this shift happen? And what kind of changes have you seen from its beginning or from your entry to this field to right now, currently?
Yeah, thank you, Shalini. So it was a series of mistakes, really, a series of failures and mistakes that led me to be interested in informatics. So I did a PhD in pure maths, and then I got a job as a lecturer teaching maths, and I tried to carry on with my research, my maths research, but I just couldn't do it. So the particular problem I had was that I couldn't find problems. I couldn't find mathematical problems that were interesting enough and also solvable. So I wasn't able to do proper maths research. So I gave up doing research for a few years. And then the university had an initiative. My university, Wolverhampton University at the time, had an initiative to promote innovation in education. And so together with a colleague, we came up with an idea for computer-based assessment. So writing programs to automatically assess the students. We had huge classes at the time, 750 students doing one statistics module, and marking took a long time. So we thought, well, maybe if we write a program that could do the marking, then we'll save a huge amount of time. So I wrote a program for several of the modules that we taught, and they got used for the assessment. And I wrote a couple of journal articles about the programs. So I kind of got back into research indirectly, but not my field. And at the same time, I did some web programming for industry. So I'd done computer programming as part of my maths degree. So I had a minor in computer programming, computer science. So I used that, and I developed it to do web programming for industry. And then the university suddenly said, okay, we don't want you to do educational research anymore. We want you to do research into your own subject area. So it was a policy shift by the university. And I thought, well, I don't want to go try maths again because I've really failed at maths. So I don't want to do that. So I was in the School of Computing and Mathematics. So I thought, well, I'll do computer science research instead of maths research. Maybe I'll have more luck with that. So I went into the library. And so in these days, you couldn't find the journals on the web. You had to look in the library. So I went into the physical library and I found the computer science journals, and I spent a few days reading the latest volume of every computer science journal in the library, looking for a topic that I could do some research into that was either interesting or that I felt that I had enough skills to investigate that topic. And I came to the Journal of Documentation, and I read Peter Ingleston's article, Web Impact Factors, and thought, okay, well, I can do a follow-up study to this, because this article has called for getting a hyperlink data from the web directly through programs rather than through search engines, which was how it was done at the time. And I thought, well, with my commercial web programming, I can write a program to get this data from the web, and then I can write a follow-up paper with that data. I thought that was fairly straightforward. So I did that, and I got a paper published, and then I wrote another paper and in the same line and got that published. And I found it very interesting. And then a year later, I realized that I hadn't actually done computer science research. But what had happened was I'd been looking at the computer science area of the library, and without knowing it, I'd gone into the library and information science area, which was right next to it in the Dewey Decimal System. So I'd accidentally become an information scientist instead of a computer scientist. So it's a bit ironic that I became a library and information scientist by making a library mistake. So I should really have stopped at the end of the computer science and gone back and checked again for something that was relevant. So I got interested in infometrics through webometrics by finding that article an interesting one to follow up, and also having developed the programming skills to make at the time a unique contribution to the field. So other people who were interested in the topic weren't programmers to the same extent. So that was my special contribution, really, writing programs to gather the web data and then analyzing the value of that data.
That's really nice. So I probably could say the loss of mathematics and, in a sense, computer science has been the gain of information science and informatics, right? Because you transitioned through various, of course, maybe, meandering in one sense, or maybe rather going back and forth. So thank you so much for your contribution. I'm sure informatics field has enriched or your contributions have been monumental. So thank you for your contribution. So having been in this field of informatics, what are the kind of evolution or how it has evolved according to you, major shifts in the landscape of informatics, and particularly because you transition from educational evaluation to primarily research evaluation, right? So looking back, what kind of changes or shifts that you see in the landscape of informatics?
Hey, thank you. Yeah, so when I joined research evaluation and Infometrics, I think there was started to be a recognition that citation analysis, which had been almost exclusively the research evaluation tool, with a little bit of patent citation analysis. So research evaluators were realizing that they needed other approaches to evaluate the impact of academic work, particularly non-academic impacts. And so the specialism that I became involved with, Webometrics, was getting that kind of data or getting data from a different source, the web. And a lot of it was assessing whether that data gave useful and viable alternative sources of evidence of the value of academic research. So either from a different origin or a different type of impact, or for different types of research that academics produce. So that was interesting research for me, but it didn't get commercialized. It didn't get wide uptake, and I think the reason was because the methods were quite labor intensive, so they were difficult to fully automate, which meant that for a business there wasn't a strong incentive to use the webmetric methods, get the data, and then sell it on to customers. But that changed when APIs, applications programming interfaces, started to emerge alongside the social web later on. So when sites like Twitter appeared, they often had a special route for programmers to get the data from the site, so an applications programming interface. And that meant instead of having a very labor intensive process to gather data from the web, which is what I'd use for webmetrics, it was now possible to get the data much more quickly and much more reliably, with the permission from the company through the applications programming interface. So that meant that we could now get data of the type that we wanted, more systematically on a larger scale as well, and also from a wider range of sources. So from Twitter, we could get maybe public interest in academic research, which we hadn't really got from previous webmetric sources. So this gave rise to the type of infometrics known as altmetrics, a term coined by Jason Priem, and that referred to potential impact data from the web gathered through an API. And this did become commercialized very quickly. So there's the company altmetric.com that sells altmetrics, and Elsevier has also creates and sells altmetrics. They bought Plum many years ago. So these, unlike webmetrics, which never really became commercialized, altmetrics did very quickly become commercialized because they were easier to create. And then this was good really for me, because it meant that the research I was doing had a more direct impact on the public. It stopped being more theoretical. Wouldn't it be great if we could do this type of research? And it became more practical. So this is the data you have, this is how to interpret it, became more the style of research. So that's been a big change, I think, access to more types of evidence of the value of academic research. And now altmetric.com has good data, and Overton also has perhaps the highest quality data that we have about non-academic impacts of academic research in terms of policy citations. So we're getting to a situation where we have a wider range of sources of evidence of different types of impact of academic research. So I think that's maybe the biggest change in infometrics. So this is a very biased perspective from me, and I'm sure if you ask other people, they'll come up with completely different answers. But that's my perspective. That's how I see it.
Okay. So from webometrics to social media analytics or altmetrics, that's a big change. So according to you, now the social media, I mean, I'm using the word social media analytics to make it a little more broader, according to me. Anyway, altmetrics. What has been that, the impact of these on research evaluation? As you said, it is very significant, that's the shape. But can you quantify, like what has been the impact of that in a way?
It's hard to quantify. I think the main difference is increasing awareness of non-academic impacts. So I can't remember who said it, but there's a famous quote, if you can't measure it, it doesn't count. And now we can measure some societal impacts, then it kind of counts. It's more easy. It's harder to forget. It's harder to forget that non-academic impacts are also important now that there are indicators for them at least. So, and yeah, so it's hard to point to specific examples because they're not, altmetrics aren't used at the scale, or not as systematically anyway, as citation-based indicators. So they're more used to support decisions than to more directly make the decisions, I think.
So in what way? I mean, maybe it is in a way, tied to the altmetrics or social media analytics or impact. But in one sense, social media itself has transformed scholarly communication in different ways, right? So how has this transformation, I mean, can you give some examples and say how this is transformed in specific fields? Because I know of, for example, in health, in public health and such areas, there has been a lot of studies about how social media has transformed scientific communication. So from a informatrician's perspective, what do you say about how it has transformed scholarly communication?
Yeah, that's interesting. I think health is maybe the best example of a field that's been transformed, where scholarly scholarly communication has been transformed. I think that may be because there's a wide interest from the public and professionals directly in academic research in the health field.
Yeah.
But I think other fields are much less impacted. So where scholarly communication, even on the social web, is mainly between existing researchers and doesn't travel so far into the public, for example. And I'm not sure if this isn't dying down a little bit outside health, because my own experience is engaging more with social media 10, 20 years ago than I do today in terms of scholarly communication. And maybe because we have so many different sources now, it's harder to know where to publicize research, which social media. There are so many. And also, if you want to monitor research on social media, it's the same problem. There are so many. Which one do you look at? Whereas maybe 10 years ago, Twitter and Facebook would be the obvious ones, whereas now there are lots. So it's hard to know where to look. So I think there's less scholarly communication outside health anyway.
So
On
there
the
is a
social
kind of
web now.
decline, you would say, in the use of social media for scholarly communication, right?
I think so. I think so. But I don't have any specific evidence of that.
I
That's just my perspective.
Yeah, that's my sense too. I'm not, I mean, I've not studied this phenomena much, but that's my perspective. And in general, I guess, not just for scholarly communication, in general, probably people have lost that kind of initial, interest and I would say hype with the social media and become, why should I share so much, right? Maybe that's the reason. Anyway. So
Yeah.
I would now like to talk about your book that you have, I would use the word sort of published on entitled Quantitative Methods in Research Evaluation, right? Wherein you have critically analyzed citation data, alt metrics, AI in research also, AI in research assessment, okay? So would you share your, clear ideas and insights and findings from this book particularly?
Yeah, sure. So I think of this book as a follow-up to Henk Mood's brilliant book on research evaluation. So that was really an important work for me, and still a brilliant book, still a brilliant book. And so my book, in some ways, a tribute to his, in terms of a follow-up to his. And I think that the unique contribution of mine is that the book now is based on empirical data, empirical evidence of the value of citation-based indicators in all fields, which we didn't have at the time that Henk Mood wrote his book. So it's a much more evidence-based book. So specifically, what has happened is that in So I was given access to a huge data set of research quality scores from UK experts for journal articles as part of our research evaluation process. So in the UK, every 6 or 7 years, there's a formal evaluation of the best outputs of all academic researchers in the process known as the Research Excellence Framework, or the REF. And so for this process, we have over 1,000 experts read the journal articles and books and other outputs of academics, and they give each one a score, a quality score on a scale of 1 to 4. And this is a very serious process that takes a year for the evaluations, and then the results are used to disseminate, I think it's £12 billion over the life cycle of the REF. So every university takes it very seriously. And also reputation. You get your reputation as a university partly from the scores that you get on this. And usually they don't share the scores of the articles. They only share the average scores for each department, or the profile of scores for each department. So it's been a wasted opportunity for SciMetrics researchers, Infometrics researchers, because the data has been thrown away. But I was given access to this data for 6 months in 2021. So I ran a series of studies assessing the value of citation-based indicators and altmetrics against the expert quality scores in all of the different 34 fields in which the UK assesses research. So this book has got a series of graphs showing the relationship between citation-based indicators and altmetrics and expert judgments of research quality for all 34 fields. So this means that the discussions in the book can be based on evidence about the relationship between expert judgments, which I see as the gold standard for research quality assessment, and citation-based indicators and altmetrics, which are supposed to be sources of evidence about the value of academic research. So the book as a whole covers a lot of the same content as Henk's wonderful book, but it is able to add an evidence-based perspective to discuss disciplinary differences and the value of academic research.
Okay. This book, the research, quantitative, this book you have put it on a preprint server such as Archive. So, just to slightly digress from the topic, are you an open access advocate, and what value you see in this?
Yes, I would like to publish everything open access if I can, definitely. So this book, the preprint is open access, and the final book, when the publisher produces it, will also be open access. So I'm very happy to for anyone to access this book without having to pay for it. And as far as possible, I try to make all of my research open access. So it's not always possible, but in most cases, the journal either publishes open access, or the journal allows me to post a preprint open access at the same time as the article is published. So I hope that's helpful, all this free research available.
So there is this connection some people make between open access and, metrics such as downloads or citations, etc. Have you found such a correlation in your research? Open access leading to more citations and more impact?
Yeah, I haven't directly investigated it, but I have read studies about it. I know it's quite a controversial area. So my gut feeling is, of course, making work open access is going to help citations. How can it not? But yeah, it's very tricky to really prove this, because so we really need a randomized control trial where articles that are essentially identical are randomly selected to go open access or non-open access, and then we'll probably see a big open access advantage for citations. But the problem is that if you take a random sample of open access and non-open access articles, they come from open access and non-open access journals, which are different. So some open access journals are brilliant, some are not brilliant, and the same for non-open access journals. So it's difficult to statistically prove that being open access is an advantage, but my gut feeling is that it is. And also, it's a good thing to do to make the work freely available for everyone, I think.
Okay, now coming to the central theme of our conversation. In your recent research, you have explored the chat GPT's effectiveness in assessing academic research or in general or journal articles. So what were the key findings regarding its accuracy and reliability? Because that's what we are more concerned about, right? In the large language models, how accurate, how reliable these data are. So, what are your findings of your research?
Okay, yeah. So I think there were three surprising findings, or three findings that were surprising to me anyway. Firstly, it was surprising that ChatGPT quality scores worked at all in the sense that they correlated positively with human judgments in all fields. So when I started investigating, I really didn't expect that at all. Not at all. So this was a big, big surprise to me.
Yeah.
So I've been impressed by ChatGPT, but I thought it wouldn't be very good at research evaluation. I thought it would be very poor. So that was a surprise. And
Mhm.
secondly, it's the correlations between ChatGPT scores and human expert judgments are stronger than for citation-based indicators. So
Oh,
ChatGPT is stronger than citations at giving evidence about the quality of academic research as judged by human experts. So
mhm.
that's the second surprise. So first of all, that ChatGPT works at all, and secondly, that it's better than citations,
Mhm.
even in the simple ways it's been applied so far. And then thirdly, the third surprise was that, and this is probably the biggest surprise of all, is that ChatGPT works if you just put the title and abstract of an article in. You don't need to put the full text. You can just put the title and abstract, and it'll give you a reasonable prediction of the quality of that article, better than citations on average.
Ah,
So that's three big surprises for me. And the
so,
third one is a big advantage that it works with title and abstracts because the copyright law in many countries, including the UK, allows you to do a lot of different things with titles and abstracts
mhm.
that you couldn't with a copyright, the full text article because of copyright conditions. So academic titles and abstract have a copyright exemption for many purposes. So you can republish them without checking author's permission, for example. So this means it's more commercially viable to use ChatGPT to make quality predictions because there aren't the same copyright considerations. And it's also cheaper to do it because you have to pay ChatGPT to run these tests on a large scale. So if to put all the articles in the ref through the top version of ChatGPT, it costs about £3,000 to get to put them through enough times to get a reasonable quality score. So
Mhm.
it's not a small amount of money, and that's for just the title and abstract. And I think it would be maybe £50,000 if it was a full text, if we had to put the full text in. So it's a substantial amount of money, and that's just under 100,000 articles. So if we had to put the whole of science in, it would be even more. So
And
there's a cost consideration and practical considerations in terms of the practical uses, yeah, of ChatGPT for this and other large language models. It's not just ChatGPT. Google Gemini works almost as well as ChatGPT, and probably DeepSeek does as well, but I haven't tested that
you
yet.
haven't tested DeepSeek yet. So there are, I have two questions that stem from this particular response of yours and also the study. So you said, no, among the three inputs, the title, abstract, and the full text, the title and abstract do as good as, let us say, without the full text. Is it, I'm just hypothesizing, or is it because internally ChatGPT or LLMs go to the full text and then extract it, or what's your take on this? Maybe they are kind of, because that's another big question, right? That leads to my next question about, the transparency of the chat GPT for research evaluation. One of the things that we all know or everybody is talking about is we really do not know. It's like a black box. inside it, what's happening, how it is arriving at that. So what's your take on that? Is it probably trying to, I mean, even though you have not input the full text, it's doing that, and that's why it's more, I would say, accurate or more correlated to the subject experts better than citation data?
Yeah, this is a really good question. So I think it's not going to the full text.
Okay.
So I have tried um, to just with the title, for example. So I've input just the title, and it doesn't do very well with just the title. So the title should be enough for it to go to the full text if it wants to. But if you just enter the title, it doesn't do a very good job. It has to be the abstract as well. Um, so I think that it's making its judgment based just on what you put in, and also context, the context of the title and the abstract. And I don't think it looks at the full text of the article. For example, I never put the name of the author in for the article, so only the title and the abstract. And ChatGPT, so I've looked at 1,000 of its outputs at least, and it's never mentioned the author or the university where the authors have come from. It's never mentioned any information that it couldn't have got from the abstract. So it seems to be really focusing on exactly what was fed into it. Although it does use its wider context to make its judgment, but it doesn't seem to be trying to cheat, if you like, by getting the full text from somewhere else.
Maybe the abstract gives enough context for it to find the full. I don't know. I'm just, I mean,
Yeah,
thinking.
I think as someone who reviews journal articles as well, I get a strong steer from the abstract. So when I've read the abstract, I think I can usually guess what my overall opinion about the article is going to be. So particularly after the abstract, I think it's often clear that it's not a good article, if it really isn't. So sometimes I'm wrong, and sometimes the abstract looks very promising, and then the article is a disappointment. So that definitely happens. So the abstract isn't always a good guide,
Okay.
but often enough, I think, for ChatGPT to use the same technique, often enough, I think the abstract does point to whether it is a good article or not. And the rest of the article just, if the full text just confirms the initial judgment.
Okay, the another question offshoot of this response is, I mean, like, to at least 2, 3 years back when GPT came into the picture, everyone was talking about hallucination as a negative aspect of ChatGPT. But these days, I read about, how especially in, I mean, like life sciences or many of these fields, that they say that hallucinations is not exactly a problem. It is actually sort of generating ideas or direction for research for scientists, right? So that's one of the things that I have been reading about. The positive, since you are given such a positive, you are positive about the chat GPT in terms of research evaluation. So that's why I thought of asking you this question. What's your take on, do you think that, chat GPT kind of inspires scientists to go in directions that they haven't thought about, or finding solutions which hadn't occurred to them?
I'm sure it does. Yes, I do use it in my own
Mm-hmm.
research. So for the book that you mentioned earlier, I used it for that book. And
Mm-hmm.
what I did with it is I put in the contents list and I asked it, is there any topic that I've forgotten to put in this book? And it suggested a few extra topics, and some of them I put in. So some of
Okay.
the, at least one of the chapters is there because ChatGPT said you need an extra chapter on this. And I thought about it and I thought, yeah, it would be useful to have that extra chapter in. So I use it quite a lot. I use it for programming as well.
Mm-hmm.
It's good at programming most of the time, although it does make mistakes. It does write a program that looks right but gives the wrong results. And less for idea generation.
Mm-hmm.
But yeah, it's good at pointing out things that you've overlooked. I sometimes enter my own articles into ChatGPT and ask it to peer review them and look for mistakes in them or flaws,
Mm-hmm.
and it gives some useful suggestions for me. So um, so I can act on those. So I haven't used it to generate initial ideas though.
Okay.
So that's something I haven't tried out. Probably the closest I've come to that is I've asked it. I had a basic idea for an article, and I didn't know what theory would work for that article. So I asked it which theories would work for this topic, and it gave a series of suggestions, which were good suggestions.
Okay.
Yeah, but it's I think it will pay researchers to be trying it out to see what it can give them that will help their creative process, but at the same time to be cautious with it. So anything that ChatGPT, so it might be hallucinating, so it might be a good idea, it might be a hallucination. So it's important to the human to be the final arbiter of whether it's a good idea or not.
Yeah, like, many, I mean, scientists have sort of talked about how science fiction has inspired them to do something,
Mhm.
right? Develop. Maybe ChatGPT's hallucination is doing that kind of a service, or it's taking people in the direction that you wouldn't have imagined, probably. I don't know. Anyway, you touched upon the, LLMs for a research excellence framework of UK. So my next question to you is, what do you think are the major challenges and opportunities that LLMs provide for a large initiative or a project such as uh, UK's RE?
Yeah, so I think I see that ChatGPT and LLM predictions as like citations.
Mm-hmm.
They're evidence, in indirect evidence of the quality of academic research, but they're not as good as human judgment. They're not as good as expert judgment. So they can be used to support experts making their judgment. Um, so, for example, in the ref in the UK, citations are used in some of the fields, not all of them. So most fields don't use citations at all, but some of them do use citations,
Mm-hmm.
but they use them when the experts can't make up their mind or they have a disagreement. So if two experts look at a paper and one says this is 4 star and one says this is 3 star, and they can't, after discussion, they can't decide which one it is, then currently they might look at the citation rates for the paper. And if it's very highly cited, they say, okay, let's put it up to 4 star. Let's agree it's 4 star. And if it's not up very highly cited, they might say, okay, we'll give it a 3 star then. So at the moment, citations are used when the experts disagree. And ChatGPT can be used in the same way. So when the experts disagree, you could take the third opinion of ChatGPT instead of citations, or maybe as well as citations, and then you can make a final judgment. But ChatGPT or LLMs, I think, are more widely useful than citations in the sense that there are more fields that they could be useful for.
Mm-hmm.
So maybe at the moment, I think less than a third of fields in the UK use citations. So we might get that up to a majority of fields with ChatGPT scores. So I think that might be a useful role that they can play in the future.
Okay. I touched upon this, the opaqueness of LLMs. And so my question to you is, like, how do you see that this can be integrated? That is, ChatGPT or LLMs can be integrated into major research evaluation studies or research evaluations themselves to ensure the transparency or the trustworthiness of the assessments. Are there any
Yeah.
approaches that you suggest?
Yes, this is a tricky issue. So ChatGPT will, or LLMs will give an explanation or a justification for any score.
Mhm.
So when I use them, I always ask them to explain the score. So it doesn't just say 3 star. It says, I think this is a 3 star because, and then it gives usually half or three-quarters of a page of justification for the score. So it's technically so it has a degree of transparency in the sense that it justifies the score, um, but also it's not fully transparent because it could also justify a different score almost as well as it justifies the score that it gives. So it is a reasonable justification, but it's not such a carefully described justification that you couldn't say, well, that's not really a good enough reason to give it a different score. So
Mhm.
it's a reasonable reason to give it a score you get from ChatGPT, but it never, in my experience, it never gives a good enough reason you couldn't say, okay, well, that also justifies a different score. So it's but that's probably also true of human experts. If you ask a human expert, why did you give this article a score of, let's say, 2? Why did you score this 2 out of 4 research quality? They'll give you a reason, but another expert could say, well, I think this is 3 out of 4 for research quality, and they'll give you just as good a reason for 3 out of 4. And it's not clear that one of them is right and one is wrong. They're just using different perspectives. So it's quite a tricky problem, really a tricky problem, understanding how much importance you can give to the justification given by large language models, and the same for human experts, really, the same for human experts. So we do have, at the heart of peer review, there's a lack of transparency, even if the experts or the LLMs give a judgment, a written judgment, an explanation for their score. And I don't see a way of getting around this, but we can be transparent about what we are using and what we don't know about them. So that would be the advantage. So you can be transparent in the sense of saying we are using large language models. We know they're not perfect, and we know roughly how they work, but we don't know the details of the information that they're using to make their decision. So there's a limited degree of transparency with their results. So this isn't a very helpful answer, I think. Sorry.
That's okay. Thank you for your insights. See, ChatGPT has recently introduced its reasoning feature, right? Has it enhanced a little bit of transparency there, reasoning feature of ChatGPT?
I haven't found a way of using it to help with the research quality score judgments. So I've found it useful for other tasks, the reasoning steps, but not specifically for the score judgment. It doesn't seem to help. But I might be wrong, and there might be a better way of using the O1 model, the reasoning model, to get more careful judgments. So I think that's maybe a future research problem to tackle.
So given your mathematical roots, how do you see mathematics and computational models influencing the way? I mean, ChatGPT is another extension, of course. We assess research impact in the future. What kind of change that you foresee in informatics due to increased computational models?
Yes, I think it will be the computational models that will help informatics more than the math specifically, the mathematical modeling. So the computational power and the ability to process large volumes of text, I think that is definitely going to change informatics. So we've relied on relatively small scale processing, and citation analysis gives you only a tiny bit of information about articles, whereas now we're able to do full text processing more easily with large language models and for more varied purposes. So I think we're going to see new applications emerging and new ways of analyzing research outputs. And I hope that we'll get more qualitative type insights into academic research than we have before. So we've focused on more numerical outputs, so we've focused on the numbers, the indicators in the past. Although we have produced visualizations too, network diagrams, for example, topic modeling, and maps of science, graphs, which are maps of science. But I think with the ability to process the full text, we ought to be doing more powerful analyses of the content of the text. But what we really need is the ability to process the full text, because the full texts are available. At the moment, many of the full texts are hidden behind publisher paywalls, so we can't analyze them. So whereas we can do virtually full science analyses on titles and abstracts because they're in the major scholarly databases, we can't do such large-scale analyses of full texts. So we combine the computational power that we have now with more free availability of full text articles, then that should give us more detailed insights into academic research, I think, in the future.
So you have seen the evolution of the field from traditional citation data to art metrics, social media. I mean, you even developed this tool to measure the sentiment analysis and things. Now we have AI assessment. So, in your view, this is my final question to you. What exactly the major, I wouldn't say just assessment, what it is doing, AI, but transformational things that you see with AI-based research evaluation? Like with full text, for example, the entire, for example, is it, I mean, let's say this is my specific question. See, since we have moved away from citation data to full text, of course, full text also has references, but will it be able to cover the entire, what I call as the visualization of the full context of the paper with the citation and everything?
It would be fantastic if it could. Yeah, it would be fantastic. So I hope that we'll get future analyses that focus on um, a more detailed contents of articles. So instead of the overall impact of the articles, it would be interesting to see studies focus on the methods, for example, comparison of methods and the way that methods relate to the methods are shared between different articles, and more specific studies of the impact of one article on another would be very useful to see. So we have some citation context analysis now where we count the citations from one article another, but also look at the context of the citation. Is it positive, negative? How does this citation help? And with full text processing, we should be able to get more powerful understanding of how knowledge transfers between papers through citations. So what specific information is used when one article cites another? So my experience is that often citations reflect very little use of information. So sometimes you have a citation which represents a lot of use. Maybe you've used the whole method, but other times you might just be citing an article to mention that it did a similar study, whereas you're not really using any of the information. So full text analyses might allow us to do more nuanced studies of the influence of academic research on other studies.
Would you say that, it would, for example, one of the other, I mean, I wouldn't say criticism, well, one of the aspects of citation analysis is whether it is positive or negative, right? Whether the citation has been to confirm or reaffirm or to negate it. So, given your background in sentiment analysis, etc., do you think that will also be, I mean, in future, we would be able to, with the help of AI, we'd be able to say how many of these citations were negative and positive or neutral, etc. also?
Yes, so I think it's very difficult at the moment. So I've written a sentiment analysis program, but I think it's not very good at detecting sentiment in academic research because the journal articles don't tend to be explicitly critical in most fields anyway. So maybe in the humanities, I think in the many areas of the humanities like philosophy, it's important to argue with other people, and it's kind of the heart of philosophy to say that other philosophers are wrong, they've made mistakes, they've made misjudgments. That's kind of the heart of what it is to be a philosopher. Whereas in most other fields, if someone makes a mistake, you just wouldn't cite their article, I think. You wouldn't mention it and then say this is wrong. You just wouldn't cite it because it's not useful if it's not correct. So it would be much rarer to be explicitly critical of someone else's study. So, but it would be useful in some fields to detect the positive and the negative sentiment towards the citations. And maybe we can have implicitly negative citations, which would be someone not citing a relevant piece of work, where we assume, okay, maybe they think it's not good enough to cite, so that's why they haven't cited it. So they haven't explicitly criticized it, but they've implicitly criticized it by ignoring it. Of course, it could be just a mistake that they didn't find it, but that would be interesting to find out, to investigate.
Okay, the one general, final, really final question. Okay, because with AI, everybody is talking about, how it's going to take away jobs and things like that, right? So, given your, I mean, the research in this particular area of AI and research evaluation, what's your suggestion for the field, I mean, future researchers in scientometrics or infometrics area? Is AI going to do everything so we don't need to do much?
I don't think AI is going to take our jobs. I think it will help us do our jobs better.
Better, yeah.
Yeah, for scientometrics. So I think we will spend a lot of our time in the future explaining to people, no, you can't trust the AI. It is helpful, but you can't really trust it. So at the moment, this is what we do with citations. Yeah, the citations are helpful, but you can't really trust them. So you have to use your own judgment too. So
True.
yeah, so no job losses due to AI, I hope anyway.
I mean, that's my general view also. In the sense, I always
Good.
say it makes smarter people, I mean, smart people smarter. So I would say if you are smart, then you can use AI to become smarter or use AI to enhance your human intelligence, right? And this applies to informatics. We come up with other ways to use AI as a assistant or a production tool, basically to enhance our work. Okay. Anyway, thank you so much for this opportunity to have this conversation with you. Thank you so much for your views and sharing your insights in this area. Let's hope we will meet once again somewhere sometime. Okay. Thank
I
you.
hope so too. Yeah. Uh, Nice to talk to you.